solve a problem and it looks like this, did I get an exact answer? I did get an exact answer, Wade. I got an exact answer. When I solve a problem and it looks like this, did I get an exact answer?
Yes.
I did get an exact answer. I worked it out exactly, didn't I? Okay? Sometimes there is a need for us to not have an exact answer, okay? To have close to the right answer. What do you think the need would be to not have an exact answer? Like, can you give me an example? When I'm estimating, but when in life would I estimate?
When you're rounding. When you're buying more than one thing.
When I'm buying more than one thing.
Like watermelon, say they're like $2.99.
Okay.
And you're buying 5 watermelons because you really like watermelon.
Right.
So you have to times that by 5.
Right. So I would say 5. Would I say 5 times $2.99?
Yes.
What would you do? 5 times what?
5 times I'm 209.
Or instead of 299 cents, I'd probably do what? $3, wouldn't I? Because $2.99 is close to. If you, I bet. My husband says that I do this. He says that I go shopping and that it'll be like $65, and I'll say, oh, I spent about $50. So he says that I estimate on the low side to make it sound a little better. Okay?
My mama, it'll be $12.49. She says 12 o'clock.
$12.49. Well, actually, she should say it's what?
1 o'clock.
Why is it 1?
Because
It's closer to 1, right? And if something costs $19.98, what do you think most of you are going to say? It's $20. I mean, do you normally say, man, when that guy made that touchdown run, he ran 14.78 of a yard? Or do you say he ran about 15 yards?
Yeah.
So sometimes there's a need to not be exact. And when we're not exact, John Kreese said that was called estimating, and that's correct. It is called estimating. I want you to find your exit ticket, and I want you to turn it over on the back. Find your exit ticket, and I want you to turn it over on the back. And let's do a little bit of talking, okay? All right? I want you to write this problem. Ooh, we got something fancy.
Estimations.
43 times 2 4/10. And I don't have an equal. It's not a hard, boom, boom, straight line equal. It's a wavy line. You know what those 2 wavy lines mean? About. About. It means the answer's about. That means they want me to estimate. They want me to round. Okay? All right, so let's look at this. Everybody looking and listening. Before I can estimate, I'm going to round each factor, each number that I'm going to multiply, okay? 43 is close to what? 40. So rewrite it underneath. 2 4/10. First of all, I'm going to look at my whole number. What's my whole number? 2. Okay? 2 4/10 is close to what? It's either going to be close to 2 or 3. It's closer to 2. What would make it closer to 3? If it was 5/10 or higher. Because 5/10 is what? Halfway. Okay? So if this is 5/10 or higher, it would round to 3. Okay, so now, what did we say it was going to round to? 2. 2 4/10 would round to 2. 2 5/10 would round to 3. Okay, now, is that mental math? Could I do that? 40 times 2 is 80. Pretty simple, right? Pretty simple. Do you agree?
Yes.
Okay, I do too. Now, I want you to come and I want you to write this as standard algorithm. Okay? Standard algorithm. Okay? You know what you're going to do for just a bit? You're going to pretend like that decimal's not there until you get to the very end and get your final product, okay? So first I'm going to do what? 4 times 3 and 4 times 4. So I'm going to do that. 4 times 3 is 12. 4 times 4 is 16 plus 1 is 17. Just like normal. Am I putting any decimals? Nope. Okay? Then I'm going to do my housekeeping. Mark out what I multiplied, erase what I carried, and put my
0.
Okay, now I'm going to multiply 2 times 3 and 2 times 4. 2 times 3 is,
16.
and 2 times 4 is.
8.
Am I still worrying about any decimals right now? Nope. Then I'm going to add it up, get my final product. It looks like 1,032, doesn't it? But do you know what that seems like to me? Way far away from what? 80, doesn't it? That doesn't seem like a good estimate at all.
Wait.
But how many digits are to the right in this problem of the decimal? 1. What is it? What is to the right? 4. The 4 is to the right of the decimal. So in my answer, how many digits do I need to have to the right of the decimal? 1. So now what's my whole number? 103. 80 is reasonable to 103, isn't it? So now does my estimate of 80 make sense if my exact answer is 103 and 2/10?
Not so much 1,000.
Not so much 1,032. But 103 is only about 23 away. Pretty close, right? Okay? All right, good. Let's write another problem. Let's try another one. Okay? Let's try 3 5/10 times 42. Okay? So write that down. Write it horizontal, just like I did. Let's estimate first, and then we'll find our exact. Okay? So when I look at it, 3 5/10. What's the whole number? 3. And if it's 5/10, is it going to be 3 or is it going to be 4? 5/10 puts it on up to 4 because that's half, isn't it? So now it's going to be 4 times, okay, let's round 42. 42 is going to round to what? 40. It's closer to 40 than it is 50, isn't it? It's 8 away from 50 and it's 2 away from 40. Okay, so let's do that. So now I can get an answer. 4 times 40 is easy because what's 4 times 4?
16.
How many zeros? 1 0. That's it. Okay, now let's turn it so that we can multiply standard algorithm. Okay, now remember, what am I going to do first? I'm going to act as though that what?
The decimal
The decimal does not exist until I get to the what? To the answer, to the very end. So what am I going to do first, guys?
2 times 5.
2 times 5 and 2 times 3. All right, after I get that, I'm going to housekeep. I'm going to get rid of what I multiplied. I'm going to erase what I carried, and I'm going to put a 0. Right? Then I'm going to multiply what? 4 times 5 and 4 times 3. All right, did you get 1,470 as your final answer?
Yeah.
Man, that estimate does not seem appropriate. 160 is not close to 1,470 because I've not put my what? Okay, how many digits are to the right?
1.
What digit is to the right? 5, 1 digit. So in my answer, I've got to put, so that's a lot closer to what? 147. 160 is a lot closer. It's only 13 away. Pretty close, right? Okay, excellent job. Excellent job, all right? Let's try another, and then we're gonna get to work. Okay? Do y'all like to write the squigglies? I love to write them. I feel so fancy.
I do not because it's so hard.
I feel so fancy. Okay?
How do you write in children?
So to estimate, I'm just good like that, Henry. To estimate, I've got to look at the whole number. What is the whole number in 15 and 16?
15.
So it's either going to be 15 or it's going to be 16. With a 6/10, what's its closest to?
16.
16. I'm going to put 16.
And teachers say that did you have a class to perfect execution?
I did not have class to perfect. Okay? 73 is going to round to what? 70. Okay, let's talk about this one for just a second. Let's talk. 16 times 70. Can I do that problem mentally?
Yes.
Mentally? You know 16 by 7?
Not now, but I can do it in like 3 seconds.
Not in your head. I mean, I could too, but is there a possibility that I can make a mistake?
But is it 112? 112.
7 times 10, 70. 7 times 6 is 42. So 70 and 42. Think so? Now, so I can do this a lot of different ways, guys. There's many different ways I can do this. I could come to the side and I could do 16 times 7 and get 112 with a what?
0.
With a 0. Let's go with that for now. Okay? We'll go with that for now, and then we'll talk about the other way next. Okay, so now, what do I need? I want to get an exact answer. I've got my estimation. If I get an exact answer, what do I need to do? Standard algorithm. So I'm going to put the one with the most digits that has 3 digits on top. I'm not even worrying about that decimal. Because it would look, what if I put 73 on top? It would be all what? Cattywampus, wouldn't it? It just wouldn't work. It would look strange. Okay, so what am I going to do first? Multiply 3 times the 6, 3 times the 5, and 3 times the 1. Do that. I believe on that one. Am I right in this?
Do what?
Okay? Did you get 468 for your first partial product?
Yes.
Okay, then you did housekeeping, and what was your second partial product?
10,920.
10,920. Okay, final answer is 14,388.
No. It's 11,300.
Oh, 11.
Yeah.
11,338. Y'all agree with that?
Yeah.
Okay, good. How many digits are to the right?
1.
1. So I'm going to have 1. So what's my whole number now? 1,138. And it's pretty close to what? 1,120. Okay, now, I want to show you something else. So I want you to put your pencil down. And I want you to look this way. Okay. When my whole number looks like this, 15, what I really need to do sometimes is to get it to be a multiple of 10. So 15 is close. What two tens is 15 between? 10 and 20. Which one is it closest to? 20. It's closest to 20. So if I do 20 times 70, that's much easier to multiply mentally, right? And estimation is all about multiplying mentally. Is it going to be as close of an estimate as the one we did before? It's not. But it's a lot easier. 7 times 2 is 14 with 2 zeros. What was the exact answer for this?
1,132.
And, okay, but if we're talking about thousands, being a few hundred off is not what? That far, okay? So that's another option. Okay, let's look at our problem set, because I think we can get a few done before PE. All right, so let's look at our problem set. Everybody look at the top, read the directions to yourself. Problem set. I'm on exit ticket. Problem set. Thank you, Ja'Cory. Okay, it tells us to do two things. It tells us to do a couple things, actually. It tells us to what? Estimate. Right here's where we estimate. Then it says what?
Stop using area model.
We've moved on from that. So you can mark a line through that, just one little line. And then what does it say? Standard algorithm. Standard algorithm. And it says remember to express your products in standard form. That means with a decimal, with numbers, things like that. Okay? All right, so let's look. Let's round 22. What would 22 round to? 20. It's pretty close to 20. Okay? 2 and 4/10. What's the whole number? 2. What's it closest to? 2. If this was, why would I round it to 3? If that was 5/10, 6/10, 7/10, anything higher. Okay, so pretty simple. 20 times 2. 40. Do you agree? Okay, now, I want you to work 2 and 4/10 is really what? 24/10. And we can put our decimal in at the end. So I want you to work 24/10 times 22. Do that, standard algorithm, and we'll put our decimal in at the end. Oh, I see housekeeping going on. I see zeros. I see people erasing carries if they need to. I said if they need to. All right, final product. You ready?
There's a whole day. 3, 6, 7, 8, 9, 10, 11, 12,
17, I think.
Okay, we are going to the gym. We're gonna